Imagine discovering that a habit you practice every week in your own kitchen, something you do to save money, avoid waste, and be practical, might actually create conditions that increase the risk of serious disease over time. For millions of people, reheating leftovers feels completely normal. It seems responsible, economical, and efficient. But what many people do not realize is that in certain foods, reheating can trigger chemical or biological changes that may not be harmless. This does not mean that reheating food is always dangerous. In fact, many foods can be reheated safely. The real issue involves specific types of food and how they are reheated. Under certain conditions, reheating can produce compounds or allow bacteria to multiply in ways that may affect the body over time. Understanding these risks does not mean living in fear of food, it simply means learning how to handle food more safely. One of the reasons this topic matters so much is because of an organ most people rarely think about, the pancreas. The pancreas is a small but extremely important organ located behind the stomach. It plays two major roles in the body. First, it produces enzymes that help digest food. Second, it releases hormones like insulin that regulate blood sugar levels. Unlike some organs, the pancreas rarely produces obvious warning signs when it is under stress. Problems can develop quietly for years before noticeable symptoms appear. Because of this, protecting pancreatic health often comes down to preventing long-term stress on the organ rather than reacting to symptoms later. Some medical researchers have pointed out that repeated exposure to inflammatory compounds in food may contribute to chronic stress in digestive organs. When the body processes certain harmful compounds, such as oxidized fats, toxins produced by bacteria, or carcinogenic molecules formed during overheating, it can trigger inflammatory responses. If these exposures happen repeatedly over many years, they may contribute to cellular damage. Pancreatic cancer, in particular, is one of the most serious forms of cancer because it is often detected late. Many cases are diagnosed only after the disease has already progressed. This is why many doctors emphasize risk reduction and prevention, especially through lifestyle and dietary habits. That brings us to the central topic: 5 foods that may become problematic when reheated improperly. Some of them are foods people eat every day. In fact, a few might already be sitting in your refrigerator right now waiting to be reheated for dinner. The first one might surprise you the most, because it involves foods that many people already know they should limit, but often still enjoy as leftovers. Think about fried foods. French fries from last night's dinner. Fried chicken saved for lunch the next day. Egg rolls or battered snacks reheated in a pan or microwave. These foods may seem harmless when reheated, but the oils used to fry them can undergo significant chemical changes when heated again. Many common cooking oils, such as soybean, corn, or sunflower oil, are highly sensitive to repeated heating. When oils are heated multiple times, they begin to break down and produce oxidation byproducts. Some of these byproducts belong to a group of compounds known as aldehydes, which form when fats degrade under high heat. Aldehydes are reactive molecules that can contribute to oxidative stress in the body. Oxidative stress occurs when unstable molecules known as free radicals damage cells and their DNA. Over long periods, repeated oxidative damage can interfere with the normal processes that regulate cell growth and repair. This does not mean eating reheated fried food once will cause disease. The concern arises when the habit becomes frequent, when reheated fried foods become a regular part of the weekly diet. In those cases, the body may experience repeated exposure to oxidized fats and inflammatory compounds. The safest approach is not necessarily to eliminate these foods completely but to change how they are reheated. Instead of reheating fried foods in more oil, using dry heat, such as an oven or air fryer, can restore texture without introducing additional degraded fats. Small choices like these can reduce unnecessary exposure to harmful compounds while still allowing people to enjoy leftovers responsibly. But fried foods are only the beginning. The next food on this list is something many people consider one of the healthiest things they can eat. In fact, it appears on almost every superfood list, and yet reheating it can trigger a chemical reaction that many people have never heard about. The second food on this list surprises many people because it is widely known as a healthy choice: leafy green vegetables, especially spinach. Nutrition experts around the world encourage people to eat more greens because they are rich in vitamins, minerals, antioxidants, and fiber. Spinach, kale, arugula, and similar vegetables support heart health, digestion, and immune function. Fresh and properly prepared, these foods are among the healthiest things you can put on your plate. However, a specific issue can arise when cooked leafy greens are stored and then reheated. The concern is related to naturally occurring compounds called nitrates. Nitrates are present in many vegetables, particularly leafy greens and root vegetables. On their own, nitrates are generally harmless and are even part of normal metabolic processes in the body. The problem begins after the vegetables are cooked and stored for some time. During storage, especially if the food is not cooled quickly or stored properly, bacteria naturally present in food can convert nitrates into nitrites. This process can occur slowly while the food sits in the refrigerator. When these nitrites are exposed to heat again, especially during reheating, they can react with certain amino acids present in the food. This reaction may produce compounds known as nitrosamines. Nitrosamines have been studied for decades because some of them are classified by the International Agency for Research on Cancer as potential carcinogens. In laboratory settings, nitrosamines have been shown to damage DNA inside cells. DNA functions as the instruction manual that tells cells how to grow, divide, and repair themselves. When that genetic information becomes damaged repeatedly over time, cells may begin to behave abnormally. The body has natural repair systems designed to fix many types of DNA damage. In fact, our cells correct thousands of genetic errors every day. But when harmful compounds are introduced repeatedly over long periods, some damage may escape repair mechanisms. One organ that may become involved in processing these compounds is the pancreas, because the bloodstream distributes nutrients and chemicals from digestion to many organs. If the body repeatedly encounters substances that promote oxidative stress or inflammation, digestive organs, including the pancreas, may experience ongoing metabolic stress. It is important to emphasize that leafy greens themselves are not dangerous. In fact, they remain extremely beneficial when eaten fresh or properly handled. The issue is specifically related to reheating them after they have already been cooked and stored. The safest ways to consume cooked leafy greens include eating them freshly cooked, eating leftovers cold, such as in salads or grain bowls, cooking only the portion you plan to eat immediately. Cold spinach in a salad, for example, retains its nutrients without the chemical reactions that may occur during reheating. Food safety experts also emphasize the importance of proper storage. Cooked vegetables should be cooled quickly and stored in the refrigerator soon after cooking. Leaving cooked vegetables at room temperature for extended periods increases the chances of bacterial activity that can convert nitrates into nitrites. These small food handling habits can make a significant difference. Most people who reheat vegetables are simply trying to avoid wasting food, not realizing that certain foods behave differently after being cooked and stored. But the next food on the list is even more surprising. It looks completely harmless. It has almost no smell and very little flavor. Millions of households cook it in large batches every week because it is convenient and affordable. And hidden inside it is a bacterium that can survive cooking temperatures and begin multiplying quietly while the food cools. The third food on this list may be the most surprising of all because it is one of the most common foods in the world: rice. In many households, rice is cooked in large batches and stored in the refrigerator for several days. Portions are then reheated throughout the week. This practice is extremely common in homes across the globe. What most people do not realize is that rice can contain a bacterium called Bacillus cereus. This bacterium is naturally present in soil and can sometimes be found on raw grains, including rice. When rice is cooked, the heat usually kills the active bacteria. However, Bacillus cereus can produce spores, which are protective structures that allow the bacterium to survive harsh conditions, including normal cooking temperatures. These spores can remain dormant during cooking and then become active later when the rice begins to cool. As cooked rice sits at room temperature or cools slowly, the environment can become ideal for the spores to activate and multiply. During this process, the bacteria can produce toxins. Some of these toxins are particularly concerning because they are heat-stable, meaning that reheating the rice later may kill the bacteria but does not destroy the toxins that have already formed. If contaminated rice is eaten, these toxins can cause symptoms commonly known as fried rice syndrome, which includes nausea, vomiting, abdominal pain, and diarrhea. In most cases, the illness is short-lived and resolves within a day. However, repeated exposure to bacterial toxins can contribute to irritation and inflammation in the digestive tract. When the gut becomes inflamed frequently, it may trigger inflammatory signals that travel through the bloodstream to other organs involved in digestion and metabolism. Researchers often refer to this connection as the gut-pancreas axis. The digestive system and the pancreas communicate through shared immune and inflammatory pathways. Chronic irritation in the gut can influence how the pancreas responds to metabolic stress. Again, this does not mean that reheated rice automatically leads to serious disease. The key factor is food safety and proper storage. When rice is handled correctly, the risk becomes extremely small. Leftover chicken. Roast chicken, grilled chicken breasts, baked chicken thighs, or even shredded chicken from yesterday's dinner often get reheated quickly in the microwave the next day. On the surface this seems completely harmless. Chicken was already cooked thoroughly the first time, it was stored in the refrigerator, and reheating it should make it safe again. But the way a microwave heats food creates a hidden problem that many people do not realize. Unlike a conventional oven that heats food gradually from the outside inward using circulating hot air, a microwave heats food by exciting water molecules inside the food itself. Because different parts of the same piece of chicken contain different amounts of water, fat, and protein, the heat does not distribute evenly. Some sections become extremely hot while others remain significantly cooler. These uneven areas are called cold spots. From the outside, the chicken can feel steaming hot, yet inside there may still be pockets where the temperature never reached the level necessary to destroy bacteria. This matters because cooked poultry can become contaminated again after cooking if it comes into contact with surfaces, utensils, or hands that carry bacteria. Two bacteria are especially associated with poultry, Salmonella and Campylobacter. Proper cooking during the first preparation normally eliminates them, but if the food becomes contaminated afterward and then reheated unevenly, those bacteria can survive in the cooler areas created by microwave heating. When someone eats chicken containing these surviving bacteria, the body may react with symptoms such as stomach cramps, fever, nausea, vomiting, and diarrhea. In severe cases, especially among older adults or people with weakened immune systems, foodborne infections can become more serious. Even when symptoms are mild, repeated exposure to contaminated food can irritate the digestive system and trigger inflammatory responses. These responses involve multiple organs, including the pancreas, which participates in digestion and metabolic regulation. The pancreas releases enzymes that break down proteins and fats and hormones that regulate blood sugar levels. When the digestive system is repeatedly stressed by infections or inflammatory signals, the pancreas may be drawn into that systemic response. This is why food safety specialists emphasize proper reheating techniques for poultry. The safest way to reheat chicken evenly is to use an oven at moderate temperature, around 175 degrees Celsius, and cover the chicken with foil so heat distributes uniformly throughout the meat. This method allows the entire piece to reach a safe internal temperature. If a microwave must be used, the chicken should be cut into smaller pieces so heat can penetrate evenly. It is also helpful to use medium power rather than maximum power, Pause halfway through to stir or rearrange the pieces, and allow the food to rest for a minute or two after heating so the heat distributes throughout the meat. Another safe option is to eat leftover chicken cold, such as in salads or wraps, which eliminates the uneven heating issue entirely. These precautions may seem small, but they significantly reduce the chances of bacterial survival and help maintain a safer digestive environment. Now we move to the fifth and final food, which many families prepare regularly: potatoes. Potatoes may seem simple and harmless, yet when they are cooked, cooled, and then reheated at high temperatures, two different chemical and metabolic processes can occur that make this food more complicated than most people realize. Potatoes themselves are not unhealthy and can actually provide important nutrients such as potassium, vitamin C, fiber, and energy. However, the way potatoes are cooked, cooled, stored, and reheated can influence certain chemical and metabolic reactions that occur inside the food. One compound that can form when starchy foods like potatoes are cooked at very high temperatures is called acrylamide. Acrylamide develops during what scientists call the Maillard reaction, the same reaction responsible for the golden brown color and crispy texture people enjoy in roasted or fried foods. This reaction occurs when natural sugars and amino acids in the food are exposed to temperatures above about 120 degrees Celsius. Acrylamide has been studied for many years because laboratory research has shown that very high levels of exposure may damage DNA and increase cancer risk in animals. Because of this evidence, the International Agency for Research on Cancer classifies acrylamide as a probable human carcinogen. The amounts found in food are generally much lower than the levels used in laboratory experiments, but public health organizations still recommend reducing unnecessary exposure whenever possible. The reheating issue with potatoes appears when potatoes are cooked once, then cooled in the refrigerator, and later reheated at high temperatures. When cooked potatoes cool down, part of the starch inside them changes into something called resistant starch. Resistant starch digests more slowly than normal starch and can help support beneficial bacteria in the gut. It may also produce a slower rise in blood sugar after eating compared with freshly cooked hot potatoes. However, when those cooled potatoes are reheated again at high heat, especially through frying or roasting, that resistant starch can convert back into rapidly digestible starch. At the same time, the second high-temperature cooking process can promote additional formation of acrylamide, especially if the potatoes become dark brown or overly crispy again. This means two different things may happen simultaneously. The beneficial resistant starch created during cooling may be lost, and the amount of acrylamide produced during reheating may increase. From a metabolic perspective, rapidly digestible starch can cause a quicker rise in blood sugar. When blood sugar rises rapidly, the pancreas responds by releasing insulin to bring glucose levels back into balance. Occasional spikes are normal, but frequent spikes over long periods may contribute to metabolic stress in individuals who are already at risk for insulin resistance or type 2 diabetes. This does not mean potatoes should be avoided entirely. Instead, it highlights how preparation methods can influence the nutritional and chemical properties of foods. Food scientists often suggest a few simple practices to reduce potential risks. If potatoes have already been cooked and cooled, one option is to eat them cold, such as in potato salad with olive oil, vinegar, herbs, and vegetables. Cold potatoes retain the resistant starch formed during cooling and avoid the extra high heat reactions that create more acrylamide. If you prefer them warm, reheating them gently at lower temperatures is generally safer than frying or roasting them again at very high heat. It is also best to avoid repeatedly reheating potatoes in oil, especially deep frying them a second time. Potatoes themselves remain a common and nutritious food around the world, but understanding how temperature and reheating affect their chemistry can help people make smarter choices in the kitchen. By paying attention to how foods are stored and reheated, it becomes possible to enjoy leftovers while minimizing unnecessary exposure to compounds that may place additional stress on the body over time. Food safety and healthy cooking habits are not about eliminating every possible risk in the kitchen, because that would be impossible. Instead, they are about understanding how certain foods behave under specific conditions and making small adjustments that reduce unnecessary exposure to harmful compounds or bacterial toxins over time. Many of the foods discussed, fried foods, leafy greens, rice, chicken, and potatoes, are not dangerous by themselves. In fact, several of them are part of healthy diets around the world. The issue is not the food itself but the combination of cooking, storing, and reheating methods that can trigger chemical reactions or allow microorganisms to grow. When people learn these details, they can continue enjoying these foods while simply preparing them in safer ways. For example, fried foods can be reheated using dry heat instead of additional oil. Leafy greens can be eaten cold after cooking instead of reheated repeatedly. Rice can be cooled quickly and eaten within a short time frame. Chicken can be reheated evenly in an oven rather than unevenly in a microwave, and potatoes can be reheated gently or eaten cold to avoid additional high-temperature reactions. These adjustments may seem small, but small habits repeated every day often shape long-term health outcomes. Another key point is that the human body is remarkably resilient. Our cells are constantly repairing damage, replacing old cells with new ones, and maintaining balance across complex biological systems. Occasional mistakes in the kitchen are unlikely to cause serious harm by themselves. What matters most are the patterns that develop over months and years. When someone consistently reduces exposure to inflammatory compounds, improves food safety practices, and maintains balanced nutrition, the body benefits from a healthier internal environment. The pancreas, like many organs, works quietly every day without drawing attention to itself. It regulates blood sugar, supports digestion, and plays a crucial role in metabolism. Protecting it does not require extreme measures. Often it simply means adopting practical habits that reduce unnecessary stress on the digestive system. Cooking fresh portions when possible, storing food properly, avoiding repeated reheating cycles, and paying attention to how foods are prepared are all simple steps that can make a difference over time. At the same time, overall lifestyle remains just as important as food preparation. Balanced meals rich in vegetables, adequate hydration, regular physical activity, sufficient sleep, and maintaining a healthy body weight all contribute to better metabolic health. These broader habits support the pancreas and other organs far more than any single food choice ever could. In the end, knowledge about food handling should empower people, not frighten them. The purpose of learning about these 5 foods is simply to give you practical information you can use the next time you open your refrigerator and decide what to do with leftovers. A few small decisions, cooling food quickly, reheating it properly, or sometimes choosing to eat it cold, can reduce potential risks while still allowing you to enjoy the foods you like. The kitchen is one of the most important places where daily health habits are formed. By applying simple science-based practices, you can make it a place that supports long-term well-being for yourself and the people you care about.